Okay, section 3 from chapter 4 on right triangle trigonometry. We talked about some of these ratios in section 2. We're going to go back and review those trig ratios, and we're going to add a few more identities to our list that will be important to us. So we're going to start with a right triangle. And from angle theta, I have labeled the opposite side, which is across from the angle, the adjacent side, which is right next to the angle, and the hypotenuse, which is always across from the right angle in the triangle. So with that set up, we can then identify the 6 trigonometric ratios that are important to us. So we're going to start with the sine of the angle is always equal to the opposite over the hypotenuse. Cosine is always equal to adjacent over the hypotenuse. And the tangent is always equal to the opposite over the adjacent. Okay, so we can take those 3 trig ratios and we're going to add 3 more trig ratios. The next is called the cosecant. Cosecant is always the hypotenuse over the opposite. Next is secant of the angle is equal to the hypotenuse over the adjacent. And then cotangent is equal to the adjacent over the opposite. Now you can see with these 6 trig ratios that there are pairs of ratios here that have the same bits of information and they're just flipped over. Those are called reciprocals. You learned in algebra that a reciprocal is when you take something is equal to 1 over that something. They are called reciprocals of each other. Okay, so that leads us into the fundamental trig identities. There are sets of identities that we can use in trig to interchange different trig ratios with each other. So we're going to start with the reciprocal identities. So sine is always equal to 1 over the cosecant. Cosine is equal to 1 over secant. And tangent is equal to 1 over cotangent. Now these 3 reciprocal identities also work reciprocals of each other. So I can say that cosecant is the reciprocal of sine. So cosecant equals 1 over sine. Secant equals 1 over cosine. And cotangent equals 1 over tangent. So I can use these ratios interchangeably in equations or solving trig problems. The next set of identities are called the quotient identities. Quotient means to divide. We talked about one of these in section 2, that tangent is equal to the sine divided by the cosine. So then it's also true that it's reciprocal, cotangent. I can flip this over. Cotangent is going to equal the cosine divided by the sine. The next set of identities are called the Pythagorean identities. And the reason they're called Pythagorean is because it's based on the Pythagorean theorem that you learned in geometry. Okay, for the Pythagorean theorem, we started with a right triangle, sides labeled ABC. And Pythagorean said that the sum of the squares of the 2 sides of a right triangle is equal to the square of the third side, or the hypotenuse of the right triangle. So that's how we come up with a squared plus b squared equals c squared. Well, in section 2, we put this right triangle on the unit circle and we relabeled the sides. We said that the side going left and right is the cosine of the angle, up and down is the sine of the angle, and then the hypotenuse we labeled as 1 on the unit circle. So if I substitute these 3 values into the Pythagorean theorem, this is going to give me sine squared plus cosine squared equals 1 squared. Okay, let's go through and simplify this a little bit. So when we take sine of theta and we square it, in trigonometry we rewrite it as sine squared theta. Same thing for cosine. So it'll be plus cosine squared theta equals 1. So this is the Pythagorean identity that relates sine and cosine together, or sine squared and cosine squared together. We can also manipulate this Pythagorean identity to involve other trig ratios to relate 2 different ratios as well. So first I'm going to take this equation and I'm going to divide everything in the equation by sine squared. So sine squared divided by sine squared, cosine squared divided by sine squared, and 1 divided by sine squared. So we know that sine squared divided by sine squared, that would be 1, plus cosine squared over sine squared will equal 1 over sine squared. Now, I can simplify this a little bit further. In the quotient identities, we said that cosine over sine was equal to cotangent. It's also true that cosine squared over sine squared will equal cotangent squared. So now I can write this as 1 plus cotangent squared. On the right-hand side, 1 over sine squared, that's the reciprocal identity, is going to equal cosecant squared. Okay? So this is another Pythagorean identity that I can use that relates cotangent and cosecant together. Okay, let's go back to our original Pythagorean identity and let's rewrite it a different way. This time I want to divide everything by cosine squared. Okay, so first sine squared divided by cosine squared plus cosine squared divided by cosine squared is going to be 1 equals 1 over cosine squared. So let's simplify this. Sine squared over cosine squared is going to equal tangent squared plus 1 will equal 1 over cosine squared is going to equal its reciprocal, which is secant squared. So here's another Pythagorean identity that relates tangent squared and secant squared together. So these three Pythagorean identities are going to be very useful to us in the future.